So whenever you have covalent bonds, there's three types of bonds that you can have. All right, the first is going to be whenever atoms share one pair of electrons. That's going to be referred to as a single bond. All right, when they share two pairs, that's going to be considered a double bond. But if they share three pairs, that's not surprisingly a triple bond. All right, so the thing is, the types of bonds that you have in a molecule are things that can be predicted from the numbers and the types of atoms that are in the molecule. All right, so let's start off by showing that with HBr. All right, so what you're going to want to do is to draw the dot structures of the individual atoms. All right, so I'm going to draw a hydrogen. All right, and we need to know how many valence electrons it has. So if you refer back to this chart right here, hydrogen is right here. So you can just look at the chart or the periodic table and say, well, that's going to have one valence electron. All right, bromine, I'll go ahead and show you. Bromine would be right here. That's going to have 7 valence electrons. So let's go ahead and put those on the atoms. All right, so hydrogen is going to have a single valence electron. And I'm just going to, one thing that's going to help is if you have a choice of which side to put the single dot on, put it on the side toward the atom that you're going to be making a bond with. All right, so I know that I'm going to be drawing a bromine atom right over here. So that's why I chose the right side of the hydrogen. All right, so let's do the bromine. All right, so remember the rule for doing this. You want to put a dot on each side before you double up. So here, 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 and we have to put 3 more. All right, so I know that that's going to end up making 3 pairs and leaving 1 electron as a single electron. All right, so I want that single electron to be on the side facing the hydrogen so that I can basically put these atoms together like jigsaw puzzle pieces. All right, so that's why when I'm placing the next 3 electrons, I'm going to put 1 here, 1 here, and 1 here. All right, and notice the way this is drawn. You can tell that these guys are the these guys right here are the unshared pairs, and this guy right here is the single electron. All right, so the term I use for any side that has a single electron, I just casually refer to that as a sticky side. All right, because think of them as being sticky. Those are going to be the sides that are going to allow you to pair up the electrons. All right, so if we pair these guys up, all right, we're going to end up having this right here. Okay, so the thing I want to point out about your finished molecule is that there's a couple things you should be able to say about it. Okay, and this rule is a little oversimplified, but it will work for the molecules that we're going to be drawing, and it'll get you used to doing these correctly. All right, so first of all, when you're done, you should have no sticky sides. All right, so when you look at your finished molecule, you should see no sides of an atom where there's a single electron. All right, so you shouldn't have a side that looks like this. All right, so I don't see any of those, so that is good. All right, we should have the same number of electrons as we started with. All right, so if we count the number of dots around these individually, we have 1, 2, 3, 4, 5, 6, 7, 8. That means we should have 8 electrons somewhere in this structure. All right, and if you count these up, 2, 4, 6, 8, they're all there. All right, so that's good. All right, please make sure you check with that, because sometimes it's very easy to either drop some electrons or add some extra. And if you count a total different from here versus over here, that means you made a mistake somewhere. All right. And the last thing, and this is pretty important, is to check to make sure that all of your atoms are now obeying the octet rule. All right, so a way to do that is I'm going to go ahead and circle I'm going to go ahead and circle the hydrogen atom right here. All right, notice when I circled that, this now has 2 electrons. All right, there's 2 electrons that we can say that it owns those or has possession of. All right, so and if you look at where hydrogen is on the periodic table, it's right up in this corner right here. So what's its closest noble gas? Its closest noble gas is helium. So, and helium has 2 valence electrons. So therefore, that means hydrogen wants to have 2 valence electrons. All right. So if you look at this right here, hydrogen has the 2 valence electrons that it wants. All right. So that's good for hydrogen. All right. Let's check it out for bromine. All right. So let me change my pen color here. Oops. Right. So I'm going to circle the bromine atom, kind of like I did the same for the hydrogen atom. And so now I'm going to draw a circle around it, showing all the electrons that it now has possession of. And when you do this, you can see it's got 2, 4, 6, 8. All right. And bromine is is right next to that that noble gas. It wants to have 8 valence electrons, and it has that. So we can check that all of the atoms have satisfied the octet rule. All right. So that means that this would be a reasonable structure for HBr. All right. And what I'm going to do to clean this up is I'm just going to draw it, redraw it, where instead of showing the shared pair as dots, I'm going to show those as a line. All right. And then I'm going to put in the bromine and put the 3 lone pairs around it. All right. Okay. So this for this next example, we're going to try making an oxygen molecule. And when you see this right here, this formula right here indicates that there are 2 oxygen atoms which are bonded to each other. So let's see if we can figure out how these guys might be bonded. All right. So first thing that we need to know is the number of valence electrons. So you can look at the periodic table. You would see that oxygen should have 6 valence electrons. All right. So I'm going to place the first 4, 1 on each side. And then I've got to choose the location for the remaining 2 remaining 2 valence electrons. All right. And so remember, I want to leave at least 1 sticky side facing towards the atom that I'm going to bond it to. So I'm just going to choose to put that extra electron here and here. All right. So I've got these two sticky sides here. So I'm going to draw another oxygen atom, but I'm not going to draw it just like this. I want to draw it so that one of its sticky sides is now facing this guy. So it's going to be on the left side. So basically, I'm going to draw the mirror image of the one that I just drew. All right. And so the first thing that you're going to do is you're going to take the atoms and you're going to join the 2 of the sticky sides. All right. So let's see what that gives us. We would have the oxygen. Let's draw the electrons that are not involved in the bonding. All right. And we've got its neighbor right here. We know we're going to make a bond to this guy. All right. And so we've got these 2 electrons right here, which have now made a bond. And so we're going to represent those as a pair, like one on top of the other. All right. So if you took a look at this and you were questioning, okay, are we done? Is this the acceptable Lewis structure for an oxygen molecule? All right. If we go back to our checklist up here, we should be able to go through this and get a little intuition. All right. So let's check our checklist. All right. All right. No sticky sides. Well, right off the bat, we look down here and we can see that we've got 2 of these sides which are still single electrons. So we have some sticky sides. So that's not good. So we haven't satisfied that part of it. we are good with the second part. We haven't dropped any electrons. We haven't added any electrons. But another thing that would tell you that you're not complete is the octet rule. All right, so if I were to take, let me highlight. If I draw a circle around this oxygen atom right here, you can see that there are 7 electrons. All right, and remember, oxygen, just like most of the atoms, is going to want to have 8. All right, so that's not good as far as the octet rule is concerned. All right, so what can we do to complete this? All right, what we're going to do is we're going to take these 2 sticky sides. Oops, got to change my pen. We're going to take these 2 sticky sides, and I'm going to use these arrows to kind of show a direction of the electron movement. And we're going to bring them in, and we're going to make an additional bond here. All right, so the way that's going to work is, first let me redraw the parts that aren't involved in the bonding. So all these were still there. All right, and then instead of having 1 pair between there, we're going to have 2 pairs. All right, and I know it's getting a little crowded there, but there should be 2 pairs or 4 separate electrons between those. All right, and that's what you call a double bond. All right, so if we're going to check our work, let me get a pen right here. I'm going to circle this oxygen atom right here. All right, and if we're checking for the octet rule now, you can see we have 2, 4, 6, 8. So it now satisfies the octet rule. All right, we have the same number of electrons. We had a total of 12 in the beginning. We still have 12 total here. And notice now there's no sticky sides. All right, and if you circled the other oxygen atom, if I were to do it like this, you would see that it also satisfies the octet rule. All right, so this would be an acceptable structure right here. And again, we would want to clean this up. Oops, let me change. All right, we want to clean this up by representing these bonding pairs as lines. And the way you do a double bond is you draw 2 parallel lines like this. All right, and then we want to go ahead and fill in the lone pairs. All right, and this is what you would call, this is a double bond. All right, so the last one's a triple bond, and we're going to demonstrate that with a nitrogen molecule. So again, the first thing that you want to do is to lay out your molecules, and we're going to put these guys side by side. And the first thing we're going to do is pair up these 2 sticky sides to make a single bond. And notice I did a little bit of a shortcut there. I could have represented these 2, when these 2 electrons pair up, as a pair of dots right here, but I know that a pair of dots eventually gets replaced with this line, so I've gone ahead and just done it like that. Just recall that this represents 2 electrons. All right, so when you're counting up your electrons, remember to count that as 2. All right, so the next thing we're going to do is bring in the next pair, the next 2 sticky sides, to make a bond. Okay, and one thing that's really important when you're doing this is to make sure that when you redraw your molecule, to not add, so when we draw that bond, we're representing it like this. The electrons in this bond were formerly these single electrons over here. So make sure when you draw the new structure with the bond that you don't also draw those sticky sides or those single electrons there. All right, that would be one of the ways that you get into trouble when you're counting up the number of electrons. All right, so we still have some sticky sides that we need something to do with. So we're going to bring these guys in. And when you do that, it's going to make this molecule right here. And so if you go through your checklist, I'll just do one real quick. If I circle this right here and you count up 2, 4, 6, 8, there's 8 electrons. Octet rule is good. That's what you call a triple bond.